Okay? Great. Okay, ladies and gentlemen. So this is kind of in a microcosm, gives a bit of a flavor of what we're doing. Okay, so for the next little component here, ladies and gentlemen, I'm going to ask you to do something a little bit different, okay? And we're making really good progress. We're most of the way through this thing, for sure. But we need to put in place a little bit of additional mechanism before we finish this out. So one of the pieces of mechanism is I do want to include consideration of the sort of food environment and the distance to stores. Okay, and in order to do that, ladies and gentlemen, I would like to go here and put in place an additional mechanism which we haven't added. Oh no, we added to the model one time, and that is a mechanism called a function. And this function is actually going to compute something about whether or not you're going to a grocery store or not. Okay. So here we go. Right. Okay. Excellent. So, ladies and gentlemen, we are going to create a function, and this function, we will put it up here, and it is going to be called, the function is going to be called probability of going for convenience food. Probability of going for convenience food. Now, my screen is a bit small, so forgive me. I'll enlarge it. There we go. Hey, oh, come in. And then here. So, probability of going for convenience food. It could have been called probability of seeking convenience food rather than of going for, but I'll leave it like this in the interest of time. Okay. This function will not require any information to do its job, so this area called arguments is left empty. However, it will return a value. So we need to select this item here that says returns, ladies and gentlemen, value. Okay. Ladies and gentlemen. So, for the function body, we're going to actually need to type in some code. Now, could this be done in this sort of flow chart that we gave before, this so-called action chart? It could be. It would be a little bit awkward to do, and therefore I'm not going to do it that way. This sort of mechanism for decision making is really nice for showing to stakeholders because they can understand this. They can understand what this means, what it's considering. Basically, the basic flow of it, the rules by which a person makes a decision. Right now, though, we're going to put in place a bit of mechanism. It's going to be a little bit more technical, and it's going to determine the probability someone goes for convenience food, okay? And it's going to take into account their preferences for sure, but also the distances. Okay, so here we go. So I'm going to create a variable called distance to convenience store. Dist to convenience store. And the value of it is going to be distance to, okay, and then it's going to be get nearest agent of main dot convenience store collection. Okay, So let me put this up on this. Oh, you know what? I said distance to. Should be distance to. Okay, distance to some agent. So let me put this up on the big screen just so you can see it. Okay, and I'm going to put it down on a separate line here so you can see it clearly. This to convenience store will be that. Java doesn't care about lines and white space between things, so you can kind of use them to your advantage. However, there are some conventions people stick to that are advisable. Okay, this to convenience store. Okay, next we're going to have a similar thing. It's going to be dist to supermarket. Okay, dist to supermarket. And how do you think this will be different? Anyone? What needs to change? Oh, I said get nearest argent. This should be agent. Use autocomplete. Don't listen to me. Get nearest agent. Distance to get nearest agent. This. Okay. Okay. What do you think needs to change for a supermarket, ladies and gentlemen? What's that? What do you think here needs to change for a supermarket?
Supermarket collection.
Yeah, it's going to be a supermarket collection in Maine. Do you remember creating those this morning? The supermarket collection and the convenience store collection, so we're going to be using those. That's why we created them. Now, I apologize. I'm just going to go for a minute here just to get some of those videos uploaded. I'm normally here a couple hours each day after the end of class, so I can upload videos, and it's kind of nice if I can get them uploading sooner. Boom. Okay, there we go. They take a long time to upload. Okay, great. So here we go. And we have dist to supermarket, dist to convenience store. Do you have those in place? Are we okay? Okay, next. Next, I'm going to have double weighted distance to convenience store. It's going to be a weighted one, which is just the distance to the convenience store times, this isn't the ideal way to do it, but it's okay, 1 minus the preference for convenience store meals. Store meals. Please don't type it out like me. You can do autocomplete, okay? And then there's going to be, I'm just trying to do this in front of you, weighted dist to supermarket. Oh, sorry, that should not be to convenience store weight. I don't know why there's a weight in here. To convenience store. Weighted dist to supermarket. Market is just dist to supermarket. Supermarket times preference for convenience store meals. Okay? So if they have a really high preference for convenience store meals, the distance to supermarket will be higher. If they have a very low preference for supermarket meals, the weighted distance to supermarket will be lower. By contrast, if they have a very high preference for convenience store meals, it'll seem like less distance to the convenience store for them. Okay, and now we're just about done. We're just about done. All we have to do is return the weighted dist to the convenience store. Here we go. Weighted dist to the convenience store divided by the sum of those two. Weighted dist to the convenience store plus the weighted dist to the supermarket. And I'll put this up there, and I'm confident I probably made a mistake somewhere along the way, but I'll help you figure it out. Okay, this is basically what we've got. Okay, so let me put these on separate lines too, just so you can see them. And here we go. That's it. That's what we got. That's the entire function. Okay, I know it's painful. I know it's painful. Okay, so these things double What that is we're so-called declaring a variable, giving a short name to this distance. Compute it and give it a nice little name we can use. Same with this supermarket. We compute this distance to the nearest supermarket, and then we call it dist to supermarket. Same thing for convenience store. And then, based on that, we create another nice name for basically a weighted version of this that takes into account preference. So if I have a really strong preference for convenience store meals, it'll seem like a further distance to the supermarket. By contrast, if my preference, if I have a strong preference for convenience store meals, it'll seem like less distance to the convenience store than it really is. And then I basically say, okay, I'm going to take the distance to the convenience store divided by the ratio of that distance to the sum of those distances, and that's going to give me some indication of the likelihood that I'm going to go to the convenience store. So if it's a very high distance to the convenience store, weighted distance, then I'm going to have a very low chance of going to the convenience store. Okay, wait a minute. Did I copy that down wrong? This should actually be, sorry folks, this should be, let's see, so if that's really, really high, so if you have the supermarket's essentially next to you, the weighted, or you have a super strong preference to it, the weighted distance to supermarket will be essentially 0, and it should be, yes, that is correct. Weighted dist to supermarket. It should be supermarket. Sorry. Okay, let me think that through. Okay, so you have a choice between supermarket and convenience store, and basically the larger distance it is to the supermarket, the more and more likely I am to go to the convenience store. So the higher this is, the more and more likely I will be to go to the convenience store. That's right. That's right. So if I have a really strong preference for going to the supermarket, the weighted distance supermarket will be very, very small. So my likelihood of going to the supermarket will be high, and therefore my chance of going to the convenience store will be low. This is computing the chance of going to the convenience store. Okay, that's I think correct. Okay, do you folks have this in place?
Yeah.
Okay, you want a little bit more time?
Yes.
Okay. Okay, pardon me, I'm just going to paste this in here just to make sure I haven't forgotten anything horrible. And because I probably did make some mistake, and I can correct it for everyone. Okay, I'm going to put it back up here, and oh, it seems to be happy. Okay, there we go. So first, I'm computing the distance, the distance to the convenience store and supermarket. I'm then weighting them by my preferences, and then I'm considering sort of the weighting of each of them to determine to where to go. And the larger the weighted distance is the supermarket compared to the convenience store, then the less and less likely I am to go to the supermarket, the more likely I am to go to a convenience store. That's right. So if the convenience store is super easy to get to, if it's next to me, basically it's going to be 0 weighted distance this, and this over this will be 1, because the supermarket is the entire distance, and so it'll be a probability of 1 of going to the convenience store. Yeah.
Nate,
Yes.
when you're writing a function, is that all Java? Or is it something specific?
That's all Java.
Okay, so basically, in terms of working out the syntax, it's just basically Java.
It's just Java. And there are just, it's hard to overexpress how many resources there are for learning Java in the web. I mean, it's a huge amount. It's perhaps, it's certainly, if it's not the most popular language out there, it is one of the top 3. JavaScript is also very popular, but different.
Yeah, to put it in perspective, all Android phones run Java. So if you're looking for somebody to build a Java application or to look at Java code or to get answers about Java code, believe me, there are a lot of people out there that know what they're talking about.
Yeah.
If you wanted to kind of just get a sense of the syntax, does it matter, is there like, are there versions that you need to pair?
No.
No.
Well, okay, I mean, there are differences, but basically it's backwards compatible.
Yeah.
So, yeah, this stuff has been codified for 15 years, 20 years. There are tons of people out there, and this is not an inconsiderable thing. Because look, I don't expect most of you to go do this heavy lifting for all of your things. Some of you might, and I admire ambition, and I think it's great. And I will be keen to try to work with you to make sure that you can have appropriate resources. And there's tons of great Java resources, including some books I could recommend for those who are interested. There are also tutorials I give as part of my boot camps, systematically 8 different tutorials on pieces of Java for any logic use. Not in general, but for any logic use. But there are probably hundreds of thousands of people worldwide, maybe more than that, who know Java. And this is not an inconsiderable thing, because if you want someone to help you with the net logo model and you look for people, there are very few people who know net logo syntax and so on. Now, a computer scientist could come and learn it, but they're not going to be able to help you immediately. Whereas if you bring this stuff to a computer scientist, they're going to be able to say, oh, okay, you just have to do this, or this is what that means. And that's an asset. It's an asset to be able to have a language that's, a standard language that your university, whatever university you work in, they're training in Java. I can't think of any decent research university where there's not a class in Java, where people aren't exposed to it. It's a standard language. Okay, so are we done with this, or a little bit more time? Are people feeling comfortable with that? Okay, so ladies and gentlemen, let's run this model. Let's run this model. Oh, wait, sorry, there's one more thing. I have to connect it up. Okay, here we go. Instead of now having this branch go according to preference for convenience store meals, we will now call, guess what?
Which branch?
Probability of going for convenience food. That thing we just built.
Which transition are we looking at?
It's this transition at the branch here. So let me put it on the big screen. It's this transition here. The condition for going to a convenience store. Yes, Dylan?
Apologies, do you put that inside a random true?
Oh, did I? I thought I put it inside a random true, but yeah. Oh, my gosh. Thank you, Dylan. Random true of this. Sorry, it would have been an unhappy camper. Sorry, and this condition is no semicolon. There we go.
Semicolon's only used if you've got another line followed.
A semicolon is used if you have a command. If you're telling it, do this, like perform this action, move to this place, assign this variable, make this variable one bigger than it is. If you're just computing a value, true or false, for example, or a hazard rate, you're not going to use semicolons. Semicolons are used for imperatives, like do this thing. And the terms of art for these things, and I apologize, it's another aspect of jargon, is we call formulas expressions. Those are called expressions. So if it's a formula to compute a value, you don't need a semicolon. We call these commands, these imperatives, these things saying, do this, we call them a statement. And there we use semicolons, okay? That is the rule. Okay, this is, how do we know this doesn't need a semicolon? Because it's looking for a condition. It's looking for true and false, so we don't need a semicolon for it. Okay, so let's compile this, make sure it's a happy camper, and we are going to run it now. Here we go. Run. Ladies and gentlemen, we are running it, and here we go. Okay, so let's take a look at a particular person. If we're dealing with behavior of individuals. Oh, you know what? It's still getting the routing information here. Okay, here we go. Let's go down to the level of a person. Population member. Here we go. And here we have people. Okay, this is someone who's exhibits a little bit of a preference for convenience store meals. Okay, let's now. ladies and gentlemen, I'm gonna teach you something here. I'm gonna teach you something about this interface that's really useful to know. And we may come back to this, but it's good to know about. If you click on a value here, you can actually edit these values and change them. So if I go click on this value, I can change it. I could say their preference for convenience store meals is 0 here. And in which case, they should be eating everything from supermarket meals. By contrast, I could change their preference for convenience store meals to 1. I do it through this by clicking on it, and by going to this thing here, I could change it to 1. And now they're going to have an overwhelming preference for convenience store meals. You'll notice them consuming them with gusto at a high rate. Okay? So in terms of experimentation, you can kind of take a look at this. Here they have a preference for convenience store meals that's overriding their geographic context. And so now, ladies and gentlemen, we're standing at the cusp of greatness. Okay? You have this in hand: food-seeking behavior, food consumption behavior, preferences that take into account distances, and now we will the crown jewel. Now we will lend it changes to health outcomes in the form of weight. May I do that? Is the food here, Jeff, or not yet?
Is that all of it covered?
Okay.
Okay, so we have some stuff here.
Okay. Okay. How many people would like to finish this off? It will probably take about 20 minutes-ish, or we could break for food and do it after. What's the preference? How many people would like to break, health break? Okay. How many people would like to finish it? Okay. Want to decide, Jeff and Dylan?
I said just because the food is here and because people might need to use the
Good.
washroom, let's.
Good. Okay. Okay. Thank you. And let's break, and we'll come back in 10 minutes and finish her off. Okay. I will post my model if anyone is seeking to use it.